Hey Manimators, it's time to learn Manim. Before we proceed, it is important to note that Manim is primarily based on object-oriented programming, OOP in short. There are numerous videos that delve into the concepts of OOP, and I'll link some of my favorites in the description. Therefore, having a solid understanding of OOP in Python is totally essential. Additionally, having enthusiasm and willingness to learn will greatly enhance your experience. Now, let's embark on this amazing journey into the world of Manim. Manim is fun to program. Everything that we want to animate goes into the construct method. You write the code, put it into the black box, and it produces the animation you envisioned. And this black box is the focus of our video. Manim can be distilled into three main component classes: Mobject, Animation, and Scene. To create our animations, we follow this particular sequence. Essentially, we want to plan what we want our audience to see and be amazed why. In all animations, the process is straightforward. First, we need to choose which type of Mobject we want to display. Second, we need to decide what type of animations to apply to these Mobjects. And third, feed that animation or the sequence of animations to the scene to be rendered as an image or video. Okay, first things first. What is an Mobject? Mobject or mathematical object is a foundation of all the elements that will be transformed in Manim. Mobject is essentially the face of the Manim, as it is what gets displayed on the screen. So understanding how to create and transform Mobjects is crucial for crafting compelling and informative content with Manim. To create and render Mobjects easier and more scalable, Manim has a specialized child class called VMobject or Vectorized Mobject. As the name suggests, these objects are rendered using vector graphics. Now, without delving into too much detail right now, it is important to know that any curve, path, or shape like circle, rectangle, square that you encounter in Manim is a type of VM object. Now, due to their vectorized nature, transforming and animating VM objects is smoother and requires less computational power than the regular M objects. Most of the time, we will be using them. M objects have other subclasses like PM object, short for point-based M object, image M object, parametric curve, SVG M object. We will explore these subclasses later in our journey. Now, the question is, how do these M objects defined? All M objects are defined by their data points or just points on the canvas. Specifically, they are placed within a coordinate system in Manim. The points of M objects are given their location in the canvas like X, Y, and Z. Now, let's move to the editor and define a simplest shape, square, based on what we have learned so far, what we have understood so far. Note that we could define the square using the built-in square class. That is not what we want to do here. Remember, M objects are defined by points on the canvas, and so are VM objects. For now, we are trying to create the same square using the points defined in our canvas. So first, we will define a class making square that inherits from the scene class, and then we are going to override the construct method. Let's instantiate a VM object with a variable sq and arrange some points as follows. To visualize these points, I'm using the dot class or the dot VM object, which takes the position of a point, and I'm grouping all the dots with the help of vgroup. Vgroup allows us to transform multiple VM objects at once. Manim's vgroup is a handy tool for binding multiple objects, and now I will add these points as corners to my sq variable and include it in my scene. Now, after rendering the class, this is the figure that I've got. But wait, this is not a closed figure. Let's understand why is that. You see, when I call set points as corners, Manim connects all these points sequentially. That is, Manim connects point 1 to point 2, point 2 to point 3, and 3 to 4. In my points array, I didn't ask Manim to connect point 4 to point 1, which results in an open square. To make it a closed square, I need to add the first point, which is 1, 1, 0, as a fifth element in the points array. Another interesting aspect of Manim is how it handles these points. It uses the mathematics of Bézier curves. Every line in Manim has two anchor points and one handle point. The yellow ones are anchors and the blue dot is the handle point. When I set these points as corners, Manim implicitly defines these anchors and handles to draw a Bézier curve. Now, we don't need to learn Bézier curves to define any shape in Manim. But this video right here, it offers a great introduction to Bézier curves. It discusses the mathematics behind them and how they are set up. The advantage of using Bézier curves is that it allows for smoothing the corners. For instance, using the make smooth function, handle points shift to transform a straight line into a smooth curve like this. This is the magic of Bézier curves. The combination of set points as corners and make smooth is bundled up in Manim as set points smoothly. So in summary, all VM objects in Manim are defined using these anchors and handles to create the curves, whether it's a rectangle, circle, hexagon, or any other shape. The principles remain the same. And in the next video, we will visit the different ways to animate this rose pattern. We will use value tracker, parametric curve, V-group, and many more things. Wait, if you have made it to this point, I would like to take a moment to thank you for watching. And if you think you have learned a thing or two, you can support the channel by various ways. One of the best ones is by sharing this video and subscribing to the channel. It is free for you, but it encourages me a lot. Thanks again. See you in the next video.